What's up everyone? Welcome back. Patrick here, moving on to another question, reviewing some fundamentals of calculus. So if we have the function x over x plus 1, we have to find this. We have to simplify this expression, f of x minus f of a all over x minus a. If you remember from grade 12 calculus, if you dealt with the alternative definition of derivatives, notice that that's what it is. There's a limit as x approaches a that's supposed to be here. But we're not going to worry about the limit, we're just going to simplify this. But later on in the course, we're going to be bringing back that alternative definition of the derivative and working with a lot of functions like this to simplify and to find the derivative of a function using that. But for now, we're just kind of reviewing the algebra skills, the fundamentals. So let's take this, let's rewrite it. Now f of x is this, so we'll have x over x plus 1 minus f of a. F of a, we would just plug in a for all the x values, so we'll have a over a plus 1 over here. And this is going to be all over x minus a. So we got to simplify this here. Now what you want to do is you want to take these two fractions in the numerator that are subtracting, and you want to combine them into one fraction. So what I'm going to do is I'm going to take this bracket and I'm actually going to work with it on the side here. I'm going to simplify it on the side and then I'll bring it back, that simplified numerator here. Just so we don't have to keep writing out that x minus a at the bottom. So notice to combine these into one fraction, we need a common denominator because we're subtracting fractions. So this x plus 1, this a plus 1, those are completely different factors. So we got to multiply this by a plus 1, got to multiply this by x plus 1 to get a common denominator. But what we do to the bottom, got to do to the top, got to do to the top. And so now what we'll end up having is x plus 1 times a plus 1, like that. And we can just combine that numerator. So we'd have x bracket a plus 1 minus a bracket x plus 1. Right, so this minus here is because of that. And so now what we can do is simplify this numerator. Notice that we could distribute this x, distribute this negative a. So we'd have ax plus x. You could also put xa. I usually like to go in alphabetical order. So ax plus x minus ax minus 1. No, minus a, sorry. Negative a times positive 1 is negative a. All over x plus 1, a plus 1. And then notice what happens, this ax, that ax cancel out. Ax minus ax, those net out to 0. So we end up having x minus a over x plus 1 times a plus 1. So this bracket here in the numerator simplifies to this expression. Notice we have now one fraction. So we would rewrite this as x minus a over x plus 1 times a plus 1. And we're going to be dividing all of that simplified to this. We're going to still be dividing by x minus a. Now notice that from here we could simplify because we have this x minus a and x minus a. So when we're dividing by this x minus a, it's like we're dividing by x minus a over 1. So it's like we're dividing by another fraction, if you will. And if you take a fraction, let's say a over b, and divide it by c over d, which is what we're doing here. We're taking a fraction, dividing it by another fraction. A over b divided by c over d. That's the same as a over b times the reciprocal of that second fraction, d over c. So we can actually take this and rewrite it as x minus a over x plus 1 times a plus 1 multiplied by 1 over x minus a, like that. And now notice the x minus a's cancel out. Right, these two factors here. It's easier to see that they cancel out like this versus like this. That's why whenever I'm dividing by something here, sometimes you'll be dividing by just an h in that primary definition of a derivative. A lot of times you'll see in future examples, I take that and I switch it to multiplying by 1 over h, or 1 over whatever that expression is there in the denominator. These cancel out, so we end up having 1 over x plus 1 times a plus 1. So that ends up being the final simplified expression for that right there.